Hello and welcome to the IPv6 presentation series. I am Amit Vartak and I will be talking more about IPv6 protocol, IPv6 packets and the differences between IPv6 and IPv4 protocols in this presentation series. This is the first presentation, so I'll be first introducing IPv6 and what's new in IPv6 as compared to IPv4, why we need this change, and I'll be talking more about this in this first presentation. In consecutive presentations, I will be talking more about address space, what is the header structure, what is auto configuration, what is stateless auto configuration, and other features which are part of IPv6. For any concerns, comments, suggestions, feel free to drop me a mail at amitcv@gmail.com. That is amitcv@gmail.com. The first question that anyone will be asking is whether I am IPv6 enabled or not, or how to know whether I am IPv6 enabled or not. If you are using Windows operating system with Service Pack 2 for Windows XP Service Pack 2, you are already IPv6 enabled. Only thing is that IPv6 suite is not installed. And to install IPv6 on Windows XP Service Pack 2, it is very simple. Just open command prompt, command shell, and write command netsh interface IPv6 space install, and IPv6 will get installed. It's just a matter of few seconds. There is one more way in which you can install it, like go to control panel, network connections, local area connections, properties, and in properties you can enable IPv6 protocol, but I guess command line options are clean and simple. And yes, in Windows also they are simple. If you are using Windows Vista, you are already enabled and IPv6 suite is already installed as well. If you are using Linux or Unix operating system, in most of the distributions it is enabled. In Fedora Code all latest distributions, or in Ubuntu all distributions, it is enabled. If you are using kernel 2.6, the full IPv6 support is available in kernel 2.6. How to know whether it is installed or not? Just open command prompt. For Windows, write command ipconfig, that is ipconfig, and you will be able to see IPv6 addresses along with IPv4 addresses. If in Linux, you can give command ifconfig and you will be again able to see the IPv6 addresses. So for finding out whether my laptop is supporting IPv6, I am currently on Windows operating system, so I will just give command ipconfig, and yes, I am able to see link local IPv6 address, which is fe80::201:2EFF and so on. So I am IPv6 enabled surely. Similarly, you can also test your machines with giving ipconfig command. Let's look at some important features of IPv6 protocol. First and very important feature why the protocol came into existence is the extended address space. IPv4 was 32-bit addressable. IPv6 is having 128 bits of address space. So 2 to the power 128 is the number of possible IP addresses, and with those many IP addresses, every grain on this earth, every sand grain on this earth can be IP addressed. Also, it enables hierarchical structure for IP addresses. Current global routing, the main problem faced by global routing is the huge routing table. Those routing tables can be brought in control with bigger IP addresses, so that the IP addresses will be assigned properly and hierarchical structures can be created. So our IPv6 example IP address is 192.168.100.1. Yeah. In IPv6 now the address will be 2001:0db8:0:0:0 and so on. Yeah, it's a big address, and the natural question is how to remember such a big address. And to solve that, the next important feature in IPv6 is given, that is IP auto configuration. Stateless auto configuration is very important feature of IPv6. Device will assign IP addresses by itself, and there is no need of manual IP address configuration or DHCP based IPv6 configuration. Yes, manual and DHCP configurations are supported, but by default the auto configuration is always enabled, and devices will be able to give IP address on themselves. That's very important feature. Stateless auto configuration is one of the most interesting features in IPv6. So let's spend some more time on stateless auto configuration. How stateless auto configuration exactly works? So when IPv6 device boots up, it asks for a network prefix. Now one or more routers on that link will be providing their network prefix to this host. So in this example, the 2001:0db8:0000:0000 is a network prefix. Network prefix is 64 bytes. So this network prefix comprises of the first 64 bytes of the IP address, and the lower 64 bytes are then derived by the host itself with the help of its MAC address or some random number to generate a globally unique IP address, 128-bit globally unique IP address. How exactly the device will be generating these last 64 bits from MAC address or the random number is the topic of discussion of further presentations. The current presentation, I will just like to explain that stateless with the help of stateless auto configuration, the need of DHCP and manual configuration is no more, and all the devices when boots up can give IP address by themselves. So in IPv4 world, we used to have static or DHCP configuration, and with large number of IP based household devices like mobile phones and TVs and refrigerators and computers and whatnot, the management of IP address is going to be a huge problem, and the stateless auto configuration exactly solves that problem. For mobile devices, again auto configuration will help to allow them configure in foreign networks as well. The next very important feature with IPv6 is simplified header format. In IPv6, the header is fixed of 40 bytes. From these 40 bytes, 16 bytes will be taken by source address, 16 bytes by destination address, so 32 bytes are over, and the remaining 8 bytes are general information. So there is only 8 bytes of general information in every IPv6 packet compared to IPv4, whose header length was not fixed. Depending upon options, the header length was changing, and since in IPv6 the header length is fixed, the routing decisions will be very fast, the processing will be very fast, because the router just has to process the fixed offsets at the fixed locations in IP header. The next important feature is improved support for options and extensions. In IPv4, yes, the options were there, but the options were inherent part of the IPv4 header itself. In IPv6, the options are included as extension headers. So IPv6 has options in extension headers. They help in fastening the processing. So the faster processing is possible. 6 extension headers are as of now defined. They are for mobile IPv6, routing, QoS, security, and so on. Another important feature with IPv6 is security at internet layer. Though IPsec is available with IPv4 now, it's optional and some implementations are proprietary. With IPv6, the internet layer security is mandatory, and internet layer will be more secured than IPv4. With IPv6, a better support for prioritized and real-time data delivery is guaranteed with the help of flow control field as well as the type of service field, which was in IPv6 only 8 bytes, here it is 16 bytes. So better control over prioritized and supported delivery is guaranteed in IPv6. There is a new protocol introduction in IPv6 for neighbor node interaction. The ARP is no more valid. For finding link layer addresses, a different protocol is there. Also, there is a separate protocol for finding neighboring nodes on the same link. IPv6 protocol is extensible with the extension headers. You can easily extend IPv6 header to support new features. So extension headers, you can define your own extension headers. Of course, if someone in future wants to add some extension headers, he can easily extend the protocol. That's it for this introductory video. Feel free to browse more IPv6 series videos on securitytube.net. Thank you.